Okay, I know this is a bit dark, but I'm going to show you a method. I think it's called the Gelosia method. It's a really easy method for doing long multiplication and for doing decimals against decimals. The downside of it is that there's absolutely no conceptual understanding. So if I want to do 34 times by 17, how I do it is I look to see how many digits are here, and there's 1, 2 of them. And so therefore I draw a line across, which is long enough to divide it into 2. So there's 3 there, 4 there. Here, this number has 2 digits, a 1 and a 7, or a 10 and a 7. But we just see it as 1s and 7s, and we divide it by the line vertically comes down, we divide it into a 1 and a 7. Once we've done that, and it's best not to build the box beforehand because your numbers may get larger. You may do a 3-digit by a 2-digit or whatever. You complete the box. You then, where this division was between the 3 and the 4, this comes down, this division goes straight across. The only thing that children get sometimes muddled up with is that a diagonal has to go from top right to bottom left, top right to bottom left. Once you've drawn that, you can do the times tables, and it doesn't matter which order you do them. So 1 times 4 is 4, there's no 10s, so there's a 0 in the top triangle. 4 times 7, as it comes down here to meet, is 28. The 2 goes in the top triangle, the 8 in the bottom. 3 times 1 is 3, no 10s, and 3 times 7 is 21. So now we extend the diagonals, because as soon as we extend the diagonals we change to adding, and we look to see what comes out here. We start off from the right hand side and we see what pops out. So 8 pops out here, 4 add 2 is 6, and that's 7, so 7 goes there. If it was a carry of 17, you put the 10 over into here. 2 add 3 is 5, so the answer, nothing comes out there. So as such, the answer is 578. Okay, I'll do one other, but now I'll do it with 1 decimal. I'll have to work quickly, okay? And hopefully we'll get a carry in this one as well. So, it's beautiful for decimals. Let's do 3.7 times by 5.9. Oh, I'm doing 2 decimals. Let's do by 59. Okay, I'll do 5.9 in a minute. So just cross that out. Do this again. 3.7 times by 59. When I've got 1 decimal, I always generally put that on the top, just because it makes it easier for the decimal to drop. Okay, so we've got 1, 2 digits, so we still make a line to take the 2 digits, the 3 and the 7 next to it. The decimal point just sits on top of the break. Here we've got 2 digits, so make the line coming down long enough, 5 and 9. We now complete the box. The line comes down and the line goes across. Top right, bottom left, top right, bottom left, top right, bottom left, top right, bottom left. Doesn't matter how you do the times tables. 5 times 3 is 15. 10 goes in the top, the units in the bottom. 5 times 7 or 7 times 5 is 35. 7 times 9 is 63. And 9 times 3 is 27. Once we've done that, we do exactly the same and we extend the diagonals, which means after this point we start to add from this side. So 3 pops out of this diagonal. 7 add 6 is 13. Add 5 is 18. Now we've got a carry. The 8 goes there, the 1 comes over into the next diagonal. 5, 3 is 8, 9, 10, 11. So 1 there, 1 to carry, and 1, 2 there. Now we haven't yet finished because we've got to let this ball release, so to speak, and as it releases it falls down and it comes out on this diagonal. So here is where it pops out. So we've got the answer of 218.3. Okay. but conceptually they actually know nothing as to why that is, which is where it has its down point, but you do get the correct answer. Let's do a decimal by decimal. So let's do 3 point, I don't know, I'm obsessed with 3, let's do 8. 8.7 times by 5.6. Okay, let's do this one then. So this is 2 digits long, so we make our line long enough, remember, to take the 2 digits. Decimal lands there. This one is also 2 digits, 1, 2. Make them long enough, so it's 5, 6. And the decimal goes on the join. Complete the box, line down, line across, top left, top right to bottom left, top right to bottom left. Do the times table. 7 times 5 is 35. 7 times 6 is 42. Yeah, I have to think then. 5 times 8 is 40. And 8 times 6 is 48. That's right. Okay, we've got our diagonals, so we start to add once we've got our diagonals from the right. 2. 8 add 4 is 12. Add 2 more is 8 add 4 is 12. Add 5 more is 17. The 10 goes over. 4 add 1 is 5, no carrying out, but the 4 pops out here. Now then, before we finish, what we need to think of is that these 2 decimal points are travelling at the same speed, okay, and they're going to meet here and crash. Now when they crash, this one here and this one here, they become 1 decimal point, but this one doesn't continue down here and this one doesn't continue down here. It goes off on this diagonal here. So it pops out here. So now we've got 45.72, and that's the answer. And that's it. But again, absolutely no conceptual understanding as to what's happened here, which is why I will possibly do the acetates for a 10th times a 10th to find out that they create hundreds. Okay? Thank you.